Hello everyone, this is Rohit Raj, and today we'll be talking about Lex token separation using Lex. So Lex is a program which lies in the core part of compilation. So Lex, what it does is it has some certain rules and definitions that we have to set it, and it works according to it. It is one of the main and foremost process that a program has to go through to get compiled and run successfully. So this will be completely different. I'll be showing you the program once. One second. So this is a program. The way you define in Lex is completely different from normal programming language. These are like this percentage and then the curly symbol are like the barriers of each and every specification, and then this is the start, and then these percentage symbols are the barriers for each and every specification. So first we'll be declaring uh, what are our definitions, what are the definitions we'll be trying to use, and then we'll be declaring what are the rules. So like the rules you give here are based upon the grammar which we use, the simple grammar which you use in the computation and everything. So you'll have to declare them. Since I declare, see, we can easily understand letter. What I declared was small a to z are letters, and small capital A to capital Z are also letters. So uh, we have declared what a letter is, and then a digit. 0 to 9 is a digit. That's very obvious. And what is an operator? These are the operators. I separated them by using or symbol over here, and then these are the key functions, like if, else, if this class function, whatever. If this word comes in the program, then this is a keyword. And then let IDs. So how do you identify let IDs and numbers? As we saw in every other programs, we directly got the output of IDs and keywords and everything. We already stored in it, but storing each and every process will be like completely difficult. To do that, we made grammar, we made use of some grammar to define them. So ID, how can an ID be? An ID can be a letter of letters or digits and letters. That if that specification comes, it's an ID. The star mark here means it's to the infinity. And then a number. A number is always a digit, a minimum one digit, and then after it can go on to infinite number of digits. So uh, star over here, the first digit is compulsory, and the second digit is, it can be amount from 0 to infinity, whatever. And then so right now what we are doing is we are giving it the use, as you can see here, user subroutines. What you want the Lex program to do for you. I want my Lex program to see if and all the keys, like the keys over here. Well, actually, you can define key instead of typing the whole thing over here. But I did type it before previously. I'll be doing it right now. So if and all, if one element from this thing comes, I want it to print out it as a keyword. Since these are the keywords, I want it to print it as a keyword. And then if an ID comes, I want to print it as an identifier. If number comes, I want it to print it as a number. And if opcode comes, like not opcode, operator comes, I want it to print it as an operator. So these are the subroutines I created. Now what the Lex program, once you start, this is YY Lex function. Once you start it, then the Lex file starts working, and the Lex program starts working. So let's see how this program gives the output. This has different compilations than many other all other programming languages. You need to compile it with using the keyword Lex. Once you compile it, you will have a file over here. Uh, One sec. Where is that? Yeah. lex yy dot lex dot yy dot c. This is the intermediate file, and once we compile it with cc, then you will get the final output that we want. So now the final output is actually stored will actually be stored in a dot out, because that's the universal A register which always stores data. Now we can directly execute it using this. So the program start working. As we haven't given input, so it doesn't show anything. I'll be giving like if this this will supposed to be an identifier, if it's supposed to be unifier, this is supposed to be operator, and 2 the 12, that's a number. So let's see, as you can see over here, it defined if as a keyword, and this is also a keyword. Oh yeah, I actually forgot this. There's a keyword called this, and this is an operator plus, and this is a number 12. So it really defined all of the things except perfectly. Let's try it again with some other non identifier. Okay, let's put uh, something like that. See, AKS is it's an identifier. Since it obeys the properties of an identifier, it is an identifier. So this is Lex, like token suppression using Lex and Lex. Thank you.